How do you know if your training is actually making you bigger without waiting months before you can visually see the difference? Strength is a pretty good measure, but it measures not just muscle growth, but also neural adaptations. Your motor cortex, the part of your brain that governs movement, becomes more efficient at coordinating the specific movement that you're training. This means that your strength progress in the short term is largely dictated by these neural adaptations. And there is very little correlation between strength and size in the short term. In the long term, strength and size correlate quite strongly in trained lifters, but then again, you have to wait a long period of time before you can reliably say, I got a lot stronger, therefore I must be bigger. By that time, you can maybe also see it. So one thing you can do is introduce what I call a witness lift. A witness lift is an exercise that you don't commonly have in your programs, but that you can occasionally do to check if you're getting stronger on it. Because if you're getting stronger on an exercise that you're not doing, that is a good indication that you are in fact getting bigger. The witness lift should be an exercise that you don't commonly have in your programs. For many exercises, front squats work really well. Many people also have machines in their gym that they don't commonly use, but you can still use those to occasionally do them and do like a 10 rep max to see how difficult it is, or to use the previous weight that you used, make a note, put it in your logbook, and then see if it's easier to do that after a long period of time. Of course, there are still some neural adaptations. If you do back squats, then your front squats also get stronger, and it's not just due to muscle growth. There's also some neural adaptation there. There's some carryover effect. Strength isn't that specific, although strength is highly specific, and as an exercise scientist, I have been repeatedly surprised by how specific strength is. It really is mostly neural coordination. So it's still useful to have these witness lifts, even if they are similar to exercises that you commonly do. Another example exercise that is useful for a lot of people is the Arnold press. Many people do dumbbell, barbell overhead presses, maybe butterfly lateral raises if you're a subscriber of this channel, other lateral raises, but not a lot of people do Arnold presses. So Arnold presses are a really good exercise as a witness lift. If you always bench press with dumbbells, you can do the barbell bench press. If you never do rows, then you can do rows as a witness lift, etc. So just pick exercises that are good measures of progress. You don't want an exercise like a lateral raise or an inverted row, where the setup for the exact movement, like how you position your body, if you stand a little bit further away from the cable, has a huge impact on your strength level. So you want an exercise that you can reliably measure progress on. This is also why machine exercises are actually very useful. The only downside then is that you lose the witness lift when you switch gym or you no longer have access to that specific machine. So usually barbell and dumbbell exercises that are a little bit more niche are great witness lifts. Another way to help you measure and quantify your progression is to use benchmark sets. If you don't know if you are progressing, you don't know if you should be changing your program. Benchmark sets help you exactly quantify if you're progressing or not. Typically in my programs, I simply use the first set as my benchmark set. So the first set dictates whether I'm progressing or not, and it dictates things like whether I'm going to do a reactive deload. The benefit of using the first set for that is that the other sets are confounded by your rest interval. So if you want to measure, say, 3 sets of 10, and you want to do 10 reps for all those sets, then you also have to measure your rest interval. Otherwise, you don't know if your performance is greater because you're resting longer or if you're actually getting stronger. Think of volume like energy balance. Energy balance and volume are both extremely important things to get right, and you can think of them as the flow over time of these things that really dictates your fat loss and your muscle growth. For muscle growth and strength development, especially muscle growth, strength development not so much, training volume over time is really the number one thing that determines your growth level. And getting the volume right is extremely important. But getting it right per workout or how you distribute it across your workouts is not so important. It's the total flow over time that really determines how much muscle you're going to gain. And that also puts the emphasis on the long term. It helps illustrate why consistency is so important. And it illustrates that things like exercise order, rest intervals, how you set up your workout, these things are not as important as how many total weekly sets and how many reps you get in those sets ultimately you get across the week. It also answers a lot of questions for people. If I miss my workout, should I still do it? Can I do yesterday's workout added to today's workout? Yes. Number one thing for most programs is the total flow of volume over time. And with energy balance, likewise, it's the total flow of energy intake over time that's really going to determine your long-term settling point for your body fat level. So you're going to settle, it's not a set point, there's no genetic determination. You end up at a certain level based on your energy intake. So if you make consistent changes in your lifestyle that decrease your energy intake, you're going to end up at a lower body fat level. It's not so much how much you eat this day, whether you have this holiday, it's the total flow of energy intake over time that's ultimately going to determine where you end up with your body fat level. So there are a lot of similarities between training volume for your training and energy intake for your nutrition. 4. Think of training to failure as a continuous variable. Most people consider training to failure a binary variable. Either you fail or you don't. Interestingly, in my experience though, a lot of people don't even fully realize what training to failure means. They do a set and then they say, yeah, that was to failure. And I'm like, no, it wasn't. They're like, yeah, I couldn't do any more reps. Okay, but you actually didn't fail any repetitions. Momentary muscle failure, as it's defined in exercise science, means you literally fail a repetition. You did not train to failure if you didn't fail a repetition. It sounds fairly obvious when you say it like this, but in my experience, a lot of people don't realize that training to failure literally requires failing a repetition. That's momentary muscle failure. Instead, the vast majority of trainees don't hit momentary muscle failure in their training, they hit what's called volitional failure in exercise science. You can actually separate things more than training to failure or not training to failure and training to momentary muscle failure and volitional failure. We can quantify training to failure for programming implications largely as a loss of force output. Because neuromuscular fatigue, as it's defined in exercise science, is the percentage loss of force output. That is the strict definition of neuromuscular fatigue, so muscular fatigue. The closer to failure you go, the more fatigue you develop. And if you go to complete momentary muscle failure, you develop a relatively high amount of fatigue, even for that amount of volume. Now, you can still train beyond failure. You can do partial reps after that point. You could do drop sets, and that will increase the amount of fatigue. Why this is important to realize is because it varies per exercise how much fatigue you're really accumulating when you hit momentary muscle failure. Some exercises inherently simply don't cause that much fatigue. For example, most types of rows, if you do them with a full range of motion and your elbow goes behind your body, at that point, the lats lose leverage. The lats cannot hyperextend the elbow. That's why you're so much weaker when you try to do rows with full range of motion rather than just getting your elbow to your side. If you're doing rows with full range of motion, therefore, you actually don't suffer that much fatigue by going to failure. And you can relatively safely take your rows beyond failure in terms of doing partial reps and only getting the elbow back in line with your body, at least for the lats. So some exercises inherently cause a lot more neuromuscular fatigue when you take them to failure than other exercises. And this means that it's good to think of failure not just as like yes failure, no failure, but think of the amount of fatigue that you're generating per set. 5. Reactive deloads. A study by Coleman et al. From 2023 found that the traditional approach to deloading, which is taking a week off after every 4 weeks of very intensive training, caused a reduction in strength gains without any benefits. The researchers therefore suggested we may be better off with reactive deloads. As the pioneer of reactive deloading, I of course wholeheartedly agree with this. How do we implement a reactive deload? Well, very briefly put, for my new subscribers, a reactive deload is when you reduce your training load for a specific exercise when you don't progress as planned and you think this was because there is excess fatigue. You have not recovered from your last workout. So last time, say you did squats 100 times 8, and now you're going to do 102.5 times 8, but you only get 4 repetitions. And you think that this is likely because you're not fully recovered yet from your last workout. If your training volume is high, your technique is sound, etc., your lifestyle is pretty consistent, you can generally make this assumption. In this case, you significantly reduce the weight for all your subsequent sets of squats. You could either just skip them entirely or do speed work. The benefit of this over traditional deloading is twofold. For one, you only deload the exact muscle groups and body parts that need the deload. It doesn't make sense to deload your pecs because your calves have not recovered from the last workout. And second, you deload when you have actual signs of overreaching, when it's actually likely that you have not recovered from your last workout. In a traditional deload, you have to kind of estimate this in advance, and it's very difficult to estimate in advance when your recovery indicators like your sleep quality, your stress level, etc. are going to be optimal or are going to suffer a little bit. 6. Most people think of their training splits backwards. They think, oh, I'm going to do a push-pull legs program, and then they're going to fill in the program. You should do it the other way around. You should think of what is the optimum training volume that I want for every muscle group in my program? What is the optimum training frequency for every muscle group? How many times do I want to train the specific exercises in my program? And how many times per week do I go to the gym? Then you put those things together and you have a training program. The training program shouldn't need to have a name. It doesn't have to be up or lower. It doesn't have to be push-pull legs. Those things are simplifications that restrict the possibilities you have to make optimal training programs. You should think of the parameters that actually matter, put a training program together, and then whatever turns out to be the program is what you get. It doesn't need a fancy name, it doesn't need a theme, it just needs to be optimized. So often when I create training programs for my clients and when I show how to create optimized training programs for my students, they're like, that's interesting, but how do you call this split? And I'm like, well, it doesn't have a name. It's just an optimized combination of training parameters that results in the desired training adaptations. That's a good program. 7. Replace the concept of systemic fatigue with mental fatigue and you're probably better off. Exercise science is very clear that the vast majority of neuromuscular fatigue is local. It is specific to the muscle group or body part that has been trained. If you train your biceps, the biceps get fatigued. It does not affect your pecs or your quads. Research has found specifically that for strength training, there is no significant systemic component. It's entirely local fatigue. However, there is such a thing as systemic fatigue, and that's mental fatigue. If you simply get tired from your workouts, you lose the motivation. Mental fatigue is a psychological mechanism that allocates resources for us and prevents us from putting excessive effort into a task that is not yielding any reward. Knowing that your fatigue in the gym is largely mental rather than physical has important implications for how you deal with it. Because if your fatigue was physical, then you should do things like a reactive deload. You should maybe consider reducing the training volume. If your fatigue is mental, this should be a highly empowering message because you know that you can safely train through it. Arnold Schwarzenegger famously said, get out! Arnold Schwarzenegger also famously said, where the mind goes, the body will follow. I hope this video gave you some new mental concepts and new ideas for how to program your workouts. If you like this type of evidence-based fitness content, I'd be honored if you like and subscribe.
You might be interested in the online Hanselman's PT certification course. You'll learn absolutely everything you need to know to get results like these. The link is in the description.